Nice to meet you, Dr. Mary.
Thank you too. So we actually had a lot of registration last night, but I guess people are still sleeping in. But it's good to have the 45 participants here today. Thank you so much for joining. It's really good to you know see the enthusiasm of students, not just majority here students. I don't know how many parents they hear and teachers and educators, but not just from Indonesia. Well,
Charming. I'm a student today.
Philippines,
Today at present.
and thank you so much for joining. It's the weekend, and also definitely Sunny and Luke joining from the US. I'd like to introduce you our speaker for today, Dr. Sunny Narayanan. This NASA Space Biology Fellow, postdoctoral at Florida State University. And he'll be sharing us today about his experience being a NASA researcher, and then the overview of the mission. And we are going to close it with the discussion with Luke as well from Axiom Space. So if you don't know Axiom Space, that will be your homework after this session to Google what is Axiom, because it will that what they're doing is very fascinating. And their founder is, correct me if I'm wrong, Luke, but he was the first person that actually started the International Space Station program in NASA, yeah?
Yeah, so our CEO managed the ISS, or at least the NASA part of ISS for a decade. But yeah, so pretty intimately involved.
Yeah, so that's a very important part of the entire space industry. And but I think for now we can hand it over to Sunny, and there you go.
Certainly. Well, thank you, Anne, for organizing, and thank you to those from Philippines, Malaysia, Indonesia, getting up early morning, Saturday morning on your weekend to join me Friday evening for myself and Luke in the United States. And I am really excited to have the opportunity to interact and share some of my space experiences, but also highlight a soon to launch NASA mission. So this will be a inter and multidisciplinary presentation. And to start, a little of a self-introduction. So then I had mentioned I'm a NASA postdoctoral fellow at Florida State University. I've been involved with our international space exploration efforts for over 15 years, ever since I was in high school, like some of you are, perhaps. With my current focus being in space medicine, life sciences. There was an earlier conversation about that. I'll actually go in a little bit more detail what that is towards the end of my presentation. For space medicine, life science is a really fascinating field with our increased activity in space, with more people going into space, and is also a unique perspective of our space exploration efforts. For space medicine, life sciences is a direction where we're studying how we reach for the stars, not to just learn about our universe, but also through this journey, we also learn a lot about ourselves. And for example, my journey, I'm a first generation academic. I'm the first in my family to go to college. I'm the first to go to work for NASA, get a doctorate, and the first to have plans to be a professor. I'm the first to be, in my family, be an engineer, a scientist, an inventor. And in retrospect, though, these firsts haven't really mattered to me that much. They haven't been that important. But really, it was the journey and the experience I've gained through all these various educational opportunities. And I've been really blessed to connect these firsts in engineering and science with our international space exploration efforts. That affects everyone here on Earth. For example, for my research of space medicine, I've been able to discover how medical conditions here on Earth happen from a different perspective, and even invent cures for those conditions. When I was young, I never thought I could combine my interests in engineering and medicine. Wasn't sure how to get involved with space exploration. But through education and opportunities early on provided by our space programs, one example being NASA, I've been able to reach for the stars to support our human space exploration efforts, like many of you will, very likely, in the near future. For space exploration is very unique. It's a journey that takes efforts from all disciplines, not just engineering, but science, communication, technology, arts, mathematics, law, business, many more disciplines. And generally, we think of these disciplines as being perhaps separate and different, though I think space exploration provides us a unique opportunity to remind ourselves that these disciplines are much more interconnected than what we may generally think. And today we'll talk a little bit about this, and we'll have various discussions and conversations, because I'd love to hear from you all as well. But let me begin with how I turned my childhood dreams into reality. And if I could do all these things, I'm really excited to see what some of you may, how you may support our human space exploration efforts in the near future. So to start, this is the logo for NASA. It stands for National Aeronautic and Space Administration. Would anyone like to share something you've heard about related with NASA? And you're welcome to type in the chat or just unmute yourself and feel free to respond. Don't be shy.
Come on, kids. I wanted to work for NASA a long time ago. But that didn't happen.
That's okay. Anne is still involved with our space exploration through NXO, which as an educator, is, I think sometimes more exciting.
I ended up in the industry, which is, yeah, slightly different from agency, but yeah, it was exciting.
Yes, so in the topic of industry and in the topic of Axiom, there's an emerging industry related with how we are with NASA related to increasing the type of projects we have in space. And I'm not going to, Anna had assigned Axiom Space as a homework assignment, but there are industries including beyond tourism, but also conducting more experiments in space, conducting, doing more science in space, telescopes. A really famous example of a NASA project is the Hubble Space Telescope. And very likely, if any of you have seen a picture of a galaxy or stars or, but we'll go into a little bit more detail, very likely may have originated from the Hubble Space Telescope.
Actually,
So
maybe
then-
the question would be, who doesn't know NASA here? Who doesn't know what NASA is here? Maybe that would be the question.
Did someone say, I don't know what NASA is?
Raise your hand if you don't know what NASA is. Does everybody knows what NASA is? Are you sure? Just to make sure, maybe you can explain, Sunny.
Sure. So NASA is a program in the United States that is an organization that develops projects that go into space. And there are many programs like this across the world. There are ones in Europe, there are ones in Asia, there are ones in Africa, South America, with the intent of bringing together engineers, scientists, educators, communicators to work together on projects that increase our understanding of the universe. And that can be of objects in space, or that could be of the Earth itself in terms of climate and weather. That could be in the context of geology, like rocks, from anywhere across the world, or from other planets, or from the moon even. So NASA has also anything related with planes or aircraft. There's a lot of research and projects that NASA has, and many other space programs have that support aviation. So one example that we'll go into is DART being a satellite project. So let's talk a little bit about, but before we get into that, I'm going to show a little bit about my journey with NASA and how that connects with our space projects.
It
So
would
show-
also help to say, sorry, in the Philippines, it would be the Philippine Space Agency, equivalent to NASA. And in Indonesia, it would be LAPAN. That's our space agency, which is actually no longer a space agency. It's now under another agency, innovation and research. But that's the equivalent of NASA in our region. Singapore doesn't have a space agency. Malaysia has Angkasa. But that's just to keep everybody on the same page. Sorry, there you go.
Oh, thank you for bringing those up, and certainly perhaps additional homework for students to explore and see what kind of programs those agencies have. But on a different note, so to begin a little bit about my journey with NASA, which began at a center called Katherine Johnson Independent Verification and Validation Facility. If any of you have seen or heard about the movie Hidden Figures, that's who this facility is named after. And I began my journey with NASA at this center and was involved with various projects, such as NASA's rockets, some of their telescope projects. They also have projects for rovers. They're kind of like robots that go to the moon or Mars and explore on the surface and have cameras and different equipment to acquire information about this environment. So it was a great experience to lead some of these projects and being part of these projects. But really my greatest memory from these experiences was the opportunity to interact and learn from so many people at NASA with their diverse backgrounds and experiences, as space industry has so many people from all over the world involved, as it really requires international collaboration with how large these projects are and how much expertise, how much knowledge is required to complete these projects successfully. So I went to college to acquire an education in engineering and biology, with my interests were to blend these fields with my interest in space, with a step in this direction being made possible by leading a team of engineers to design, build, and fly experiments on aircraft that simulates weightlessness in space. So this aircraft is pictured on the top left here. And here we are, my team and I, in our flight suits, getting ready to board this aircraft. And on the bottom left here, you can see a image of us while the aircraft is simulating weightlessness, and our experiment is experiencing microgravity, and we're observing it and conducting various tests, but we're also notice some of us floating and also experiencing weightlessness as well. And we also had the unique opportunity to explore the NASA Center, including visiting mission control. Have any of you heard about, have heard the phrase mission control before?
Anyone?
No, not from a movie, or I
We're
think
very shy students here.
and then you suggest the Armageddon as a preview to.
Oh. Hi, can you mute the audio? Okay, I'll mute it. Nobody. Here you go.
That's
Go
okay.
on.
Well, so mission control is the home base for space missions, where NASA or anyone from the from any space agency will have headquarters there to watch and observe what is ongoing with space projects. And it's the central location where they'll communicate and keep track of how the mission is ongoing. And we had the opportunity to go to mission control in Houston, Texas, where Luke is, and where the Mercury, Gemini, and Apollo missions, where the NASA the team was located during those missions when space exploration was first starting. We even got to watch the movie Apollo 13. Huge fan of the movie. We got to watch it in that control center, and imagine what it was like for the actual individuals during that movie to respond to the events from that mission. So additionally, after undergraduate, I was really lucky to complete my doctoral training in a space-related area, specializing in space medicine and life sciences. Really thanks to a incredible woman at NASA Johnson Space Center, Judy Hayes. She and I are pictured here on the left. She is the division chief for NASA's biomedical research program. And by asking her questions, by having a conversation with her, sharing my interests and learning more about her experiences and how she got involved with space, I learned about the field of space medicine and learned how to learn about this program, this doctoral program that focused in the area. And through that interaction, I learned about the research and got involved and connected my interests in engineering and biology in a really special way. And additionally, I was also during my time as a doctor, during my doctorate, I also had the opportunity to be involved in NASA Johnson Space Center, the home of human space exploration in the biomedical research division. We had the opportunity to learn and be involved directly in human space exploration efforts. This included seeing various habitats such as the future lunar Martian rover, picture on the bottom here, and here are some of us actually inside the rover that's located at NASA Johnson Space Center. And we got to tour, be involved with various research labs. Different topics included microbiology, immunology, space radiation, space food, nutrition, exercise. There's really anything you can think of that one can do on Earth is likely has some space-related connection to it. So now at Florida State, I study how, specifically how astronauts adapt to the space environment, but I also like to chat and love about space projects in the engineering field as well. So I see questions in the chat that I see some are being answered, but we'll also be taking periodic discussion breaks. So I'll also answer those questions during that time. So I've shared a little bit about my personal journey. And as I mentioned, now we're going to talk about our soon to launch mission to an asteroid. So what does that look like? Well, here's a visual, a representation of this mission, of the DART space probe and its destination, its target. Okay, so there's a few different objects located in this image. Would anyone like to share their thoughts as to what some of these objects are? And again, you're welcome to type in the chat or just unmute yourself and
Don't be shy. Come on, it's not every day that you meet a NASA researcher. Hello.
Asteroid.
Yeah.
Oh, I see a couple of response. Okay, so thank you, Sunita and Mark for sharing some answers. And Kazana, I apologize if I was unclear. My question was, what are some of the images? What are some of the objects located in these images? What do you think they are? So Sunita and Mark responded asteroid. So that's what is located towards the upper location of this image. There are two asteroids, and that's unique. We'll talk about why this asteroid system was specifically chosen for this mission. And Luke commented a vacuum. Yes, we'll talk about what a vacuum is. And Kamang, thank you. You mentioned the spacecraft. Yes, so this spacecraft here, image here, is DART spacecraft. We'll talk a little bit about why it looks the way it does, how it was designed, what the different components of it are. But before we're into talking about DART mission, let's talk about what asteroids are, first of all. So some of you point out that the image had an asteroid. So for this specific mission, there are two asteroids. The smaller one in the picture, in the previous picture, it's called Dimorphos. Didymos was the larger asteroid. And both make up what's called a binary asteroid system. Binary meaning that they orbit each other as they travel through space. Now, when impacted by the payload, Dimorphos will move from its current orbit to its new orbit, which is the intent of this test. So, sorry, I was on the wrong slide. So there'll also be observations made from Earth while this is going on to observe where the spacecraft is located, what it's doing, and how it's adjusting its trajectory. So here we see the spacecraft, and here we see Dimorphos, the smaller of the two asteroids, orbiting Didymos, and after impact, will be moving into new orbit. It's a very important element of this test, and we'll go into why that's important later on in our presentation today. So I'm going to play a short video, and let me turn the audio down first because it may be loud.
DART is the Double Asteroid Redirection Test.
Can everyone hear the video?
Hit by asteroids and mixes of asteroids all the time. Every year or so, we get hit by things maybe the size of a table. The kind of object that DART is going to visit is an object that's about the size of the Washington Monument. Those kinds of objects hit us every few thousand years, and they would cause severe damage on a regional scale.
We chose to do this demonstration at a binary asteroid. It's called Didymos. This is actually approximately the shape of the main asteroid. It's called Didymos A, and its moon, Didymos B. What DART will do is DART will hit the secondary. When it hits the moon, it will change the orbit period. When it changes the orbit period, it affects the timing of when the moon moves in front of or behind the primary.
Mostly what we're looking to do is change the speed of the incoming object by maybe a centimeter per second or so. That's not very fast, but if you do it enough seconds in advance, you can cause it to miss the Earth entirely.
DART is a part of a larger collaboration called AIDA, which pulls in all the experts of the world who can help their governments predict and understand what it is that they can do and should do in the event that there was an incoming threat. The DART mission that APL is pulling together will be the first mission in that flight line.
Okay, so there was a lot of details with that video, but two I wish to highlight were one, international collaboration and how this project has individuals from all over the world involved, and then two, a more technical term, velocity or speed. So that was mentioned, and it's very important factor when thinking about how space projects happen and how they travel, and also in particular the how this mission will accomplish its objective in terms of the spacecraft DART having an effect on the asteroid target. So we'll talk a little bit about more of that in detail. But before we do that, we're gonna have a minute or two where I'd like for y'all to think about this question. The question here being, if you had the opportunity to design a space mission, what might it be? Would it be a asteroid mission too, or perhaps something different? Okay, so I see Seto, you mentioned spacecraft with nuclear bomb, maybe.
That's not very nice.
Space debris mitigation from Sylvie, okay.
Nobody wants to find aliens.
Kazana does find aliens. Space mission to Mars, spacecraft for asteroid mining. Great, light speed engine for space travel. These are great answers.
Asteroid
All
mining.
these answers. Sorry, Anne?
Yeah, asteroid mining, of course, space resources. That's pretty much what everybody is doing in the industry at the moment. Majority of it. Space mission to another galaxy. That would be soon. How?
That'd be a really exciting one.
I don't think we'll ever be doing that, unfortunately.
No.
Other solar systems, most likely, yes, but that's optimistic.
Too
Well,
far.
with some of the with the enthusiasm we're seeing in this audience, it may happen sooner than later.
I agree. This is awesome.
Black
Great.
hole.
So thank you all so much for all Mars terraforming. These are fantastic ideas.
I like the Noah's Ark comment. Yeah, that's a good one.
And what I really like though is how different all of these are. Drug discoveries in space. Sorry, Anne, you're saying?
Yeah, Queenie mentioned drug discoveries in space. Queenie is our coordinator in Philippines. She's a doctor.
Great.
Mine resources. Live on a planet other than Earth. We're trying to do that. Be patient. Exoplanets, dark energy. So we have great potential of space researchers here, and getting people excited here.
Yeah, so we're gonna have to do this in say in a couple of years and have everyone share their updates with how their space project is going.
And the conclusion is apparently everybody wants to get out of here. They all want to go to
either different stars or out of the galaxy. Yes.
I'm happy in Bali, but you all want to go to like another galaxy.
We'll have to see
Okay,
if there's
carry on.
a Bali-like location in another galaxy. Okay, so thank you all for sharing your ideas. And related with that is there's so many different space projects that could be possible. Travel related, location related, the type of project. So there's really so many different ways to get involved with space exploration projects. But we're gonna switch back to asteroids for a bit. So that's what we talked about Dimorphos and Didymos are. And to show a bit about what asteroids are, so for those unfamiliar, asteroids are considered minor planets and are different from comets and meteorites. And a minor planet is an object in space that orbits around our sun that is neither a planet nor a comet. So it's a very specific definition. So would anyone like to guess what a comet is or a meteorite, or share their share what they know about what a comet is? If you've heard about it. Okay, so we'll talk a little bit about what comets and meteorites are. With meteorites being very similar to, oh, I'm seeing an answer from Mark. So comets are frozen leftovers from formation of the solar system made out of dust, rock, and ice. Yes, so they're also jokingly called as snowy snowballs in space, with meteorites being similar to asteroids but being much smaller and generally made out of rock or metal. And oftentimes these meteorites can be fragments from comets or asteroids too. They're also located in different spots across our solar system. Comets generally stretch far out beyond our solar system, while majority of asteroids and meteorites are located in specific areas, in particular the asteroid belt outside Mars, but before reaching Jupiter. But then there are also additional clusters where asteroids and meteorites are located, called Trojans, Greeks, Hildas. And there are a lot of them. So would I like to take a guess as to how many asteroids there are? Are there 10? Are there 1,000, a million, somewhere in between? Don't be shy. There's no right or wrong answer. So they're actually, okay, thank you, Kumang. Close to a million. There's about 800,000 asteroids currently detected. And most of these are located in the asteroid belt outside of Mars. Though many of these asteroids have stable orbits around the sun, there are also many that have orbits that cause them to approach the Earth. And these are called near-Earth object asteroids. This visual here shows the near-Earth orbit asteroids. In the middle of the sun, and the Earth is over here, the third big rock from the sun, and the green dots are all the near-Earth orbit asteroids. There's quite a few. I said there's close to a million. So there's maybe half of that number that approach the Earth. So there's quite a few of the ones that we know of. And actually, I misspoke earlier. So there's about 26,000 specifically that we're aware of that may pass close to the Earth. So there's several of them. And how do we find these? How do we find any asteroid in general? Well, we have various ways of doing that. We have telescopes on Earth that I'll share some ways to get involved with citizen science telescope programs where you could even look for asteroids yourselves, maybe discover a new one even. And then we also have telescopes in space. This telescope is a special telescope specific for asteroid hunting. It's called WISE, or Wide Field Infrared Survey Explorer. But all you have to do is remember it as WISE. And how it studies and explores for asteroids is by looking at a very specific type of light that is unique to asteroids to detect them. And so far, it's found many thousands of asteroids. And one thing I found cool about this mission is that it was launched over a decade ago and was supposed to only last for less than a year, 11 months. But ever since it's been launched, it's still running. So that's been over 11 years. So it's pretty incredible when space projects like WISE, some other examples include the Curiosity and Opportunity rovers that last beyond their anticipated experiment time frame, and then collect even more information, help us discover even more about our universe. So it's pretty incredible. So the name is WISE, typed in the chat. So we're going to take actually another breakout session. And now I'm going to ask you all to think about if you could study any space object besides an asteroid, what would it be? It could be Mars, galaxy, it could be a black hole. Think of it as being like a crew member along the Guardians of the Galaxy, where you're traveling in space. And so, okay, we're already getting a lot of, okay, dark energy, black hole, lots of black hole, dark matter, dark energy, Titan satellite, okay. Get the answers, the moon, okay. I'm gonna ask you another question. Are there different galaxies and different black holes? Other galaxy, yes. Okay, Sylvie's interested in planets on different planets. Andrew asked a great question. What happens inside the black hole? And what happens if an object? That may be another seminar. Anne, what do you think? Yeah, there's really a lot for us to imagine, for us to discover in space. These are just a few examples. Thank you all so much for sharing objects that you'd maybe be interested in searching for. Maybe the next time you all work with a telescope, maybe you could find some of these objects that that you're describing. Okay, so we've talked about a lot about asteroids. You all are professional asteroid hunters now. You've learned everything that there's need to know about asteroids. But how do we, in the context of this DART mission, what is the intent of this mission? So we're going to talk a little bit about the spacecraft that's imaged here. So it stands for, the mission is DART. It stands for double, because it's a binary asteroid system. So that's why there's a D. Its objective is a binary asteroid system, and to redirect one of the asteroids to new orbit. And then also, it's a test. So that's where the acronym DART originates from. And with it being a test, what does that suggest? Well, it suggests that there's going to be more missions like this in the future. It's a very unique mission because it's the first space project to test moving an object in space into a new orbit. In the context of tests, this is what DART looked like before it was launched, while it was being tested. So as you can see, there are some engineers, some scientists that are wearing specialized equipment to interact and work with this spacecraft. You can also get a sense of scale with how large this spacecraft is, how tall it is, compared to the people sitting in this environment. And you also may notice different components. We're going to talk about those in a moment, but one component I'm going to focus on here is this golden material that is covering this spacecraft. And this gold material is found in on many spacecraft. It's a special foil. It has a really special name. It's called a space blanket, and it's being installed in this situation. The space blanket is made out of special material. So there's also materials research to create specific materials that are needed for space missions. Yes, Seto, thank you very much for the question. So that gold layer provides protection from the space environment. It can handle, space is very cold, but it can also get very hot, depending on being shaded, say, by the Earth or being exposed to the sun. And there's also space radiation. So this space blanket, this material, provides protection from radiation as well. And then also, this foil is covering the main body of the spacecraft, but then there's also this gold cylinder that you all can see here on the left. Now, this gold cylinder is not actually this gold foil, it's actually the solar panels, part of the spacecraft, but in this position, it is, the solar panels are coiled and wrapped before they're released. That happens when the spacecraft is launched into space. So we're going to talk about a little bit more of that later. So here we have a computer drawing of the main part of the spacecraft itself, which includes a star tracker and a sun sensor for navigation to help the kind of like a GPS for the spacecraft to help find its way as it's navigating through space. There's also a very special engine called NEXT. It's an ion engine, which is different from, say, the engines used with rockets. And there are also, though, thrusters located on the spacecraft, which are more similar to the kind of engines on rockets that allow the spacecraft to maneuver, make very, very precise adjustments while it's traveling in space. There's also a component called DRACO. DRACO is a very important part. It stands for Dimorphos, Reconnaissance, and Asteroid Camera for optical navigation. So that's a very complicated acronym, but an important word as part of that acronym is camera. So this DRACO is a camera that will take images of the asteroid as DART is approaching it to get information about moving, targeting, size and shape of the asteroid, and in particular to calculate the exact precise location for where the impact should happen. And if that doesn't happen, then the redirection of Didymos, the small asteroid that will be relocated around Dimorphos may not happen correctly. So it's a very precise calculation, and we'll also acquire some images of the surface of Dimorphos and learn more about asteroids during that process as well. So Jung had asked a question about what kind of defenses do we have to protect from the condition of the Earth from that many asteroids? Well, this is exactly the kind of protection that we are testing. So it's a very important mission. And also equally important is putting the spacecraft together, which requires unique environments to test various elements to the spacecraft, including structure, the electronics. Sorry, I'm hearing someone's mic. Okay, sorry about that. So there are electronics, there are different parts of the spacecraft, and this environment here aims to test as close as possible for the spacecraft before it gets launched into space. Would anyone like to take a guess as to why that's important? Why might it be important to do testing of the spacecraft before it flies into space? Well, we want to make sure we conduct a lot of testing while we still have the spacecraft here on Earth to make sure all the parts are working. Because after testing and after the spacecraft sits on the rocket and is launched into space, then we can't do any more testing. So we are very limited at that point in terms of checking to make sure all the different parts of the spacecraft are working correctly, are put together correctly, can complete the task that is needed for the mission. So there's a lot of time and effort placed with setting up the asteroid, or I'm sorry, setting up the spacecraft before it gets loaded onto the rocket. Exactly, Seto. So how to ensure that the mission goes smoothly and successfully. So having said that, let's put things a little bit in perspective in the context of scale. So there's a very tall building in Dubai, in the United Arab Emirates, called Burj Khalifa. It's the tallest building in the world at 830 meters. Now we've been talking about two asteroids, Didymos and Dimorphos. Here we can see Didymos drawn on a scale next to the tallest building in the world. And it's competing pretty closely in terms of how tall it is. Then the smaller asteroid, Dimorphos, is over here on the left side of this image. And it's also pretty tall compared to some of these other examples of structures, like the pyramids of Giza, the Eiffel Tower, Statue of Liberty. And where does DART fit compared with these two asteroids? Well, it's the DART spacecraft is all the way over here on the left, and it's 19 meters tall. And that's actually 19 meters with the solar panels deployed. The actual spacecraft is much smaller than that. So it's very, very, very small compared to Dimorphos, which is the asteroid that it's moving. Okay. The spacecraft also weighs compared to the asteroids, at least, not very much. So the spacecraft itself weighs about 670 kilograms. Okay, about the weight of a car. While Dimorphos, would anyone like to take a guess how much Dimorphos weighs? Is it something similar? Is it 10,000 kilograms? Is it 100,000? Is it a million? More than a million? Yes, no? Okay, well, it's actually even more than a million. Dimorphos, the smaller of these two asteroids, weighs close to 5 billion kilograms. Okay, so we're talking about a spacecraft that weighs about as much as a car. And I can't really think of an example of something that weighs 5 billion kilograms, but it's probably more than what the tallest building in the world weighs, even. So it's pretty incredible that this tiny spacecraft can push this asteroid into a new orbit. So, so when the DART spacecraft collides with Didymos, that will certainly, someone mentioned nuclear bombs with a rocket, something along the lines. Well, it'll be very much a detonation in terms of when the spacecraft impacts Didymos. It'll require a lot of energy to cause it to move. And based on that, based on what we learned about asteroids and DART, what do some of you think about planetary defense? Is it something that is maybe important, requires unique projects? Okay, so Kamang, you asked the question, how the spacecraft provides enough force to change the momentum of the asteroid? Yes, so that's a great question. With the asteroid being as heavy as it is, and with the spacecraft being magnitudes, many magnitudes less, the movement is related with how fast the spacecraft is moving. And that relates with kinetic energy. Does anyone remember is anyone familiar with the equation for kinetic energy? Yes, come on. Thanks for, yes, Luna, you're correct as well. So it's half times the mass times velocity squared. And mass is also different from weight. Weight in space is 0, but mass still exists in space. Now, with regards to velocity, the spacecraft is moving exceptionally fast and has to precisely hit the asteroid along the line of its orbit. So the asteroid is not moving towards the spacecraft, and then the spacecraft is impacting it. The asteroid is moving away, so it has velocity already, and then the spacecraft is also impacting it at a greater velocity to nudge it into its new orbit. So it's, in short, moving very, very, very quickly to add kinetic energy to Didymos to cause Didymos to change its orbit. And Mark had mentioned, with regards to planetary defense, that it involves identifying potential asteroids, comets that could collide with Earth, prevent these objects from reaching our planet, and assist in learning how to protect our planet more effectively in the future. That's exactly right. So those are all important factors related to why we are conducting planetary defense missions, and what we think about when organizing these kind of projects. And to provide a little bit more information with regards to how fast DART is moving and how it's moving, we have this video where in this video, we have a few objects moving. The ones to pay attention to are dark blue, which is for the Earth, and pink is for the DART spacecraft. Green is for the asteroids, Didymos and Dimorphos. With DART being scheduled to launch just a couple days, November 21st, it's scheduled to make contact with these asteroids in a little under a year from now. So it's also moving very, very fast because it has a very long trip ahead. It's covering 500 billion kilometers. And it's traveling at an average speed of 30 kilometers per second. So when perhaps in a car on a interstate or highway, perhaps one may be traveling maybe anywhere from 50 to 100 kilometers per hour. Okay, this is kilometers per second. So it's covering this distance. And then when, so you think, so it reaches the Didymos, it'll go even faster to add even more kinetic energy when it impacts the asteroid. And when it reaches the binary asteroid system, there was a camera I mentioned before, Draco. These are images from Earth, or what the asteroids look like. We see a tiny dot here at the top. These are sequential images, so multiple images taken, and then we see a shadow. That shadow is Didymos, with a tiny dot being Dimorphos. And multiple of these images are taken to generate this 3D image. So this is a 3D representation of what the asteroid looks like. And okay, let me explain the video before. So after DART makes impact with Didymos, not only will Didymos, the orbit change, but there'll be fragments of Didymos that get scattered into space. And they get scattered in a way that is visualized here. They form a cloud around the asteroid. And the asteroid would actually eventually travel close to the Earth, which is illustrated here. But the asteroid itself won't make contact with the Earth, but rather the fragments from this asteroid will. So there'll actually be another mission that will collect these fragments. And these fragments from the asteroid will allow us to conduct scientific studies of the asteroid without actually having to visit the asteroid itself. So that's another unique element of this mission. So here are here is a image of the spacecraft in a vacuum chamber. The vacuum is intended to simulate the vacuum of space. Now, when I say vacuum, is anyone familiar with what that term means? What does vacuum mean? Okay, Swandi says you're not familiar. That's okay. Well, vacuum in space means, so it can mean negative pressure. In space, it means emptiness. It's not entirely, space is not entirely empty. There is dust, but very, very, very small quantities of it in space, even in the vacuum of space. But it's, for the most part, very very empty and very cold. So what this environment tests is, how does the spacecraft handle being in a simulated vacuum environment? So it's a very important test to make sure all the different electronic components, for example, can work in that environment. And here is a up-close image of the propulsion, the engine that this spacecraft utilizes. It's an ion-based engine. So this blue, like fog that is being released by the engine, are the particles being released to push the spacecraft further. And here we have an image of the spacecraft right before it's being loaded. So these are all the components of the spacecraft: the solar panels, the Draco camera, the DART spacecraft, and it's resting on a chamber to be loaded onto a payload system. Now I'm actually going to play a video of the launch itself. So there will also be some audio. Make sure it's low. Okay, so you all saw a picture of DART and a payload. So it's sitting on top of this rocket, and it's taking off, launching off. And there'll be a stage when it has reached space, and what are called fairings are separated from the payload compartment of the rocket. And this is the DART spacecraft before the solar panels are released. So that's what's happening here. They move outwards from the spacecraft and unfold very precisely. And we didn't talk about this, but the solar panels are incredibly important because they acquire energy from the sun and turn that into electricity that DART uses to stay active.
Who is that?
Now we see this chamber was released, so DART's ion thruster, camera system, the Draco camera system, can start taking measurements. And here we see it traveling through space. And there is the mission objective, the binary asteroid system. Here we can see it's still having an orbit close to Earth, but now it's approaching the asteroid. That's the Draco camera system taking images of the asteroid. Particularly the Dimorphos. Now it's approaching, has its target calculated, and impacts. And that'll change the direction of the orbit. And you all saw a dirt and debris being released. And that'll expand and be collected later. And yes, fairings, question by Fabian, fairings are to protect the DART probe while it's resting in the payload compartment of the rocket. Okay. So how could you all get involved with being professional asteroid hunters, so to speak? So there are many ways to get involved in terms of citizen science, and these welcome to share, and you all can explore these different opportunities and programs to get involved. And some of these are projects where one with perhaps your own telescope or community shared telescope can collect images and share those images for data tracking or asteroid tracking. And there are also ways to look at asteroids based from ground stations across the world to that take images of various objects in space, including asteroids, and look at images, identify the images to what asteroid they are. So there are certainly many ways one can get involved at any age in terms of involvement with space-related projects. In addition, there are more missions. We talked about planetary defense, and an important element of planetary defense is being able to counter the trajectory of any near-Earth orbit asteroid. So DART is the first of many. There's another mission called Hera that'll be taking place in the near future, as well as NASA has a near-Earth observation program. And another mission planned, similar to DART, to test being able to redirect an asteroid in the context of planetary protection. So Anne, I know we're going a little bit over time. Am I okay to keep going, or?
As long as the kids are happy.
Okay. Well, I'm gonna.
Are you all enjoying this? Are you all enjoying this? I hope you are. Okay, let's go. Because we want to get into the space biology part where it gets more exciting about us living in space, right?
Yes, for sure. Yes. So that's what we're transitioning to right now. So here we're talking about our international Artemis project, where space programs across the world are planning to go to the moon together and return to the moon, having people live on the moon and around the moon. So related with that, our time in space has been primarily been in low Earth orbit, or very close to the Earth, but still in space. The moon is a very different environment. So what have we learned about living in space in low Earth orbit so far? Well, we've learned it's pretty fun, actually. We've talked about in space there's no weight, so everything floats. For example, this is astronaut Kajal Lindgren, and he's on station and opened up a bag of fruits. And the moment you open the bag up, all the fruits started flying out. And he's you can see his reaction to that. He's very enjoying that very much. So it's certainly a lot of fun to be in space. And similarly, we have a few astronauts here on the right imaged, and you can see one astronaut floating while the rest are sharing their perspectives and experience about what it's like in space. And we talked about Apollo earlier, but a really cool movie about a space mission is Apollo 13. So maybe some of you have seen it before, or if you're interested in learning more about what a space mission is like, this is another example. The Martian is another one. There are quite a few. But I'm actually going to now open up another, I'm going to have to switch my screen share for one moment. I'm going to share a video of an astronaut playing a sport in space. Okay, I'm going to play a video. Can you all see and hear it?
Hi, this is Scott Kelly aboard.
So this is astronaut Scott Kelly. So the astronauts that were in the pictures in the previous, they're all in the International Space Station. Our space station orbiting low Earth orbit that has been orbiting the Earth for I think close to 20 years now. And it's a really amazing place where we experience microgravity, we experience space environment, we can complete all sorts of experiments. We live in space. It's astronauts live in space for many months now, up to a year now, and do all sorts of while also living in space and eating in space and sleeping and exercising. They also conduct experiments and complete projects. They also like to have fun too. So this is an example of a science experiment. It's also pretty fun.
Do a little demonstration of these paddles. They're called hydrophobic paddles, and they repel water, kind of like a raincoat.
These are special ping pong paddles.
Space station. They allow you to play ping pong with a ball of water, and
Probably wouldn't be so neat if he moved the paddle out of the way. May cause a little incident, but that's an example of screen share of how space environment is very different. If I were to try that here on Earth, I would make a big mess. Life in space is very different, but there are also ways to conduct science experiments that increase our understanding with what life in space is like. As there is the reason why that water bubble could form the way it does because there's lack of gravity, and why the astronauts were floating. But there's also other environmental factors like radiation, that we have science facilities across the world that allow us to simulate the space environment and conduct experiments here on Earth. And we can conduct a lot of experiments here on Earth and learn more what it's like to be living in space and what happens to our astronauts when they live in space. And particularly, these facilities can also test and simulate what it's like to live on the moon or around the moon or even Mars. So the name of the facility is called, one facility is called Brookhaven National Laboratory. And I'm here with some colleagues and friends conducting some experiments at these science facilities and studying how radiation affects us as we travel into space. And it was also involved with a few biomedical studies. These are just some pictures of myself and the team. Here we are in front of a SpaceX rocket. Sitting on top of this rocket is our biomedical experiment that actually traveled in space, traveled to the International Space Station, and spend time on space station, being experienced in the space environment. And then our international team of scientists, were pictured here on the right, we're waiting preparation for this experiment to return and studying the effects of what happened to space. And the picture on the right here is actually a picture I took of the rocket launching from Florida. And this is our mission patch from the mission, where we were studying how we adapt to the space environment and how that relates to astronaut health. And having shared a little bit about what space is like, what do y'all think? Would you want to live in space? No?
Yes, but for time.
I'm sorry?
Just for a moment, maybe.
I think we had the form, the registration form asking for the if they want to migrate or evacuate, right? I'm gonna check out the latest graph because bone density affected, of course. You get you age way much faster, so that's not good.
But I'm seeing a lot of yeses. So yes, bone density, and there are other adaptations, but most of the adaptations are adaptations that recover when we return to Earth. And a significant reason for that is because of a lack of gravity, for bone density in particular.
So 69.8% said, maybe I would like to learn more about living in space or moon and Mars and its impact to human health. And 12%, no, I love Earth and will stay here even though I might die from an asteroid impact like the dinosaurs. And 6.2% said, yes, absolutely, I do not want to die. And then 12% says, yes, but I do not want to live in space permanently. So majority is actually interested or not. It says, maybe I would like to learn more. So what would you like to learn more about living in space?
Great. Well, there will certainly be future events to talk in more detail of what happens what happens to us when we go into space, and how we adapt to the space environment. Space biology is certainly in particular now, with there being so many more people traveling in space than ever before. and the research that I share a little bit about and have ongoing studies, science studies of, are studies that will also share insight with regards to how we adapt to a lunar gravity environment and Martian gravity environment. So it's certainly a very exciting time to think about what it's like living in space, and in particular with our Artemis project, where we're planning to return to the moon together in the very near future. And we'll also learn a lot more about space almost every week, every month. There's people traveling in space, and there are more habitats being built in space. And so we'll also learn more about what it's like living in space, and in particular, how that relates with what life may look like long-term on the moon, on the surface, or around the moon, and on Mars. And all that is related really to the great team, to make that all possible, great team of individuals from across the world involved with this mission, the DART mission. These are some of the team members from the DART mission that shared their diverse backgrounds and experiences to make this one particular mission possible. But there's certainly, as you all had commented at the very beginning, talking about missions to other galaxies or planets, studying life on other planets, or the existence of exoplanets. There's certainly many space projects, and looking forward to future events, and looking forward to speak more about life in space. And thank you all again for joining me on your Saturday morning and being incredibly engaging, asking great questions, for your great comments. And to conclude, I'm happy to, there may be a few more questions now, or
let's read the questions one by one, or comments from the bar and chat box. And it will be lovely if you can join us on the video so we can interact and engage face to face now. And turn your mic on as long as it's not noisy in your background, and you can talk with us. So Fahreza, where are you? If we live in space, are we gonna look like human in Wall-E movie? You mean like the rover, like the
yes. So in the movie Wall-E, there were people that adapted to the space environment, but one thing that people in from the movie were not doing as much, that astronauts spend a lot of time doing, is exercising. So a lot of the adaptations that happen in space are lessened by doing routine exercise. So things like running or cycling, or can help with a lot of the adaptations of space. And there's a question about living in space being safe. Yes, it's safe. The environment that astronauts in are like very similar to a home, or where there are there's protection from the deep space environment. There is food to eat. There is there are places to sleep. There are movies and games to play. So it's and there's also a lot of really cool science experiments to do, to get involved with, and see how the space environment can lead to new discoveries, lead to innovation of science questions in a way that can't be done here on planet Earth. And we need more scientists, more more engineers to conduct those kind of space experiments. So hopefully, we'll see some of you in a space environment in the future conducting some really cool science experiments.
I want to introduce Queenie from Philippines and Havis from Malaysia. So yay!
Hi, nice to meet you.
Hi, nice to meet you guys.
Hi, both of you. Can you co-host it with me? There's so many, so many comments and questions and from the chat box. So feel free.
Yeah, I can see everybody is interested to know more about space, right?
Yeah, go
Hmm.
Havis.
Okay, so yeah, I lost the track. Where the last question actually?
The last
Which one? Which one? The last one?
Who you want to live in space?
Oh, okay, okay. So that one is the last one, right?
Do we have right and enough resource for living in outer space? That's a question from Rishang. Where's Rishang? Rishang, where's
Uh-huh.
and Seto? You're the one that wants to nuclear bomb the space. You're gonna be listed now on the radar.
I apologize. What was the question?
That was Rishang.
Yeah, the one's from Rishang. So yeah.
Do we have right and enough resource for living in outer space? Living right. Do we have enough resource for living in outer space? We are trying to develop space resources. So and in orbit manufacturing, so that we don't have to carry all the heavy equipments and everything from Earth, which is going to be very, very expensive. But we're going to try and use space resources, mining it from the moon or the asteroid, so we can 3D print it, and so we can print our homes on the moon and in Mars. Sylvie, you raised your hand. Sure. Actually, I have a question, Sunny. So, given that, like we've cataloged the entire 100% of the asteroids and sudden, but there's always unexpected asteroids that hit, like the ones in Russia and so forth, right? I mean, us being in Indonesia on the equatorial, we always have space debris falling down because we're, from the geostationary satellite, and sometimes like SpaceX second stage fell here the other day at someone's backyard, So, and its majority is always in either Sumatra or Java, which is high density population. So let's not talk about asteroids. We get space debris all the time. Hopefully it's not going to land in the middle of the road or elsewhere, right? But the options, of course, not just space exploration and people want to live in space because, I don't know, maybe they're bored of living here, or just in terms of adventure. Physiologically, like, how does this relate to genetic mutation? Or is that a sensitive subject in terms of, MBLG and genetics? Actually, that was my science major that I dropped. I wanted to do genetic engineering, but like, because you would. We need to. I think I saw somebody the chat box saying like our body is accustomed and has evolved and adapt to live on Earth. So like I'm trying to also understand like how we evolve as a species, not just in the higher consciousness of the subject of space where we connect with everybody, all nationalities working together. That's more of a cooperation side of things. But I mean, the most important thing is physically, right? And physiologically, like we also eventually evolve and adapt, like how the evolution of a reptile and fish and so on, and suddenly they can live from amphibian, right? will we become like that too, or do we need to genetically mutate our DNA and or be humanoids in a way as well, cyborgs?
Yes, that's a really interesting question, and certainly in the context of genetic adaptations and evolutions, in the context of space is a different environment, and the adaptations that develop to astronauts or crew when they travel into space could lead to long-term adaptations. In terms of whether they become evolutionary, we have not spent enough time in space for to approach the question of do those develop into long-term genetic adaptations. But certainly once we, in particular, go back to the moon and spend extended periods of time in the moon, there may be genetic adaptations, for example, where the moon having less gravity on Earth, people on the moon may start to become naturally taller, or because of less of a gravitational pull, but in turn, those adaptations, those long-term adaptations, will take very long periods of time. But that can certainly happen. And there are also mutations that could be accelerated because of radiation exposure. Radiation will cause DNA changes at a faster pace than the radiation exposure from space, I should say. So yeah, there could be with the cyborg part. Exoskeletons are a thing, so there's a little bit of that already happening. But maybe the people that live on the moon, then if they stay there for a long period of time, once they return to Earth, if they visit, they may have to wear exoskeletons just to support them from not being in being a different gravity environment. But that is was what engineering and discovery is all about.
So it's either we become Hulk or we become cyborgs. What are the options, right?
Well, there may be multiple options. So we'll have to see we'll have to see and find out.
But so the most it would be bone density, and then higher risk of, what did you say, cardiovascular, cancer. Those are all scary things. So, but like if we solve that problem, then we will also solve our problems here on Earth. Don't you think so?
Yes, and without giving away too much of the space medicine presentation, but yes, so there are adaptations of the heart, of the brain, of our entire bodies adapt to being in space, which is very different than, say, from medical conditions here on Earth, where they're very more focused generally. So space provides us a unique environment to also see how the body adapts to factors that don't exist here on Earth, and learn about how gravity, there are specific gravity genes, there's specific gravity proteins, there's specific that may be related with how diseases happen, or different pathways that are being activated. So we learn more about physiology, we learn more about biology just by going into space. And in the context of whether the adaptations are negative, well, there's also by studying those and learning about what those adaptations are, we learn about ways to develop cures, to develop treatments. Exercise being a really fantastic treatment. as well as diet with regards to radiation. Diet or supplements that provide that are rich with antioxidants, that are rich with certain vitamins that are like vitamin D for bones in particular, or enriched with calcium, or other components to supplement and provide extra nourishment to the organs that are, and in turn also that could be helpful for patients here on Earth. Those new innovative new food and diet technologies that are developed, and yeah.
Well, hopefully once we are able to do that in the century to come. Hi, Tala, nice to see you. Then once we already migrate there, we're not going to be hit by another asteroid or space debris, or getting hit by Russia or China with their anti-satellite technology, because that would be awkward. Like,
That would be, yes. We would want to avoid as much space debris, whether it be on Earth or as much as possible.
Pak Kunjaya, do you have any question? Pak Kunjaya is my mentor in astronomy. He's a lecturer from Bandung Institute of Technology, which is our MIT.
Thank you for joining us. Nice meeting you.
Okay, nice to meet you. Yeah, thank you. It's a nice presentation. Give more insight to us about the asteroid and how we can live in outer space. Yeah. But my concern is if we try to destroy an asteroid, and the debris of the asteroid may harm our environment, for example, our satellites or space stations and so on. How do you think about that?
Yes, so in the context of the debris that's generated from the asteroid impact, that's a great question. And certainly is a challenging engineering problem. In the context of satellites or spacecraft in general in space, they are constantly interacting with particles flying through space. There are micrometeoroids, and then meteoroids, so anywhere from the size of nanoparticles, so 10 to the minus 9 of a meter, up to centimeters. Those are constantly traveling through space. So the satellites are shielded for the most part to be protected from that. But also the location is also relevant. So in the context of where most satellites are, and I mentioned geostationary orbits or polar orbits, those orbits are generally in the confines of what's called the Earth's magnetic field, called the Van Allen belts, which also provide some shielding from smaller particles that so when we start talking about more space exploration around the moon or on the moon, there certainly may be more likelihood of space debris events, which adds further justification for conducting these kind of space missions like DART. And we need more of these to figure out more ways to handle that problem and test that problem and be sure we're prepared for that kind of scenario, whether with more satellite activity in low Earth orbit or more projects ongoing around the moon. It would be a shame to have a lunar mining base, but then have an asteroid plummet into that mining base, and then we lose all the capability to do lunar mining on the moon after all the effort that would have gone into that. So so it's a matter of preparation, and missions like DART are a step in that direction.
Okay, thank you.
Thank you for that response. You have anything else to ask? Let's go to the chat box.
Certainly. So I see question from Kazana about recommended institution for undergraduate students to learn about NASA. So yes, there are universities across the world that one can get involved with space-related projects. There are certainly many different universities in the United States to get involved with space research. And I'm happy to provide suggestions. Welcome to reach out to Anne and ask for, I'm happy to communicate with everyone and provide suggestions. Welcome to reach out about my contact information, and happy to help with identifying programs that would be of specific interest with you and your interest in space research. And now Kamang asked a question about if there is a plan B in case if DART plan fails. So going back to my emphasis on testing, if there are, so these spacecraft are also designed with multiple levels of what are called redundancies. So backup parts, so to speak, in particular with the electronics and the computers that control, and even, for example, the thrusters that adjust the positioning of the spacecraft. There's 8 of them. There's multiple of those systems. So if something were to fail, there's compensation by another system to that can serve as a backup or can adjust. But ironically, if there was a collision with another asteroid or something like that, then there's not much that can be done in that situation. then the primary mission objective fails. But spacecraft are designed to have backup systems.
It'll be very worrying if it doesn't have one, and that's not going to solve the problem. So, any more question? Is there any environmental effect from space activities such as space tourism, space mission? Did you answer that question?
Yes, I'm scrolling back. There's a question about is the DART spacecraft made to see if it's possible to change the course of the asteroid by Fabian. We'll have to check back in a year from now, and that's when it will actually happen. And with the
October as well, October next year, it will impact. It has enough kinetic energy to break it. Wow, really?
Move it.
To move it, yeah. I mean, wow. Okay, that's something. Space environment.
I'll also share a link to tracking the mission progress. Live, and then there'll be an opportunity to see the impacts live as well.
Okay, that's exciting. But anyway, we will be doing space biology and more into that details soon with Sunny again. Yeah, but that would be more towards, would it be space medicine and space biology?
Yes, both topics.
Not on the asteroid session. So then you will be able to learn more about that in further detail. I don't know, either maybe in January for the space camp, online space camp. That'd be good. So I think we have a good turnout. I hope you all enjoyed this. So much question, good discussion. Would be great if you can turn on your camera now so we can have a group photo before we all forget. Thank you, Ibu Mary, Miss Mary, Queenie from Philippines, Harvest. Are you still there from Malaysia? We do really want to connect students from not just Indonesia, but also from other countries, so they can start talking, they can start community building. And so hopefully someday soon as well, we can do a challenge. And it's not just going to be for Indonesian students, but students from, you know, the region can work and collaborate together, because that is an exercise of space cooperation. It's not just going to be one country. It's not just going to be one university or one organization. You have to learn how to cooperate with other people, other organization effectively, like how they built the International Space Station, like how they cooperate in the UN Outer Space Office. And if you're interested, you can also join SGAC, Space Generation Advisory Council. There's a lot of you know, early exercises to do before you actually jump into the industry and for a mission. So, shall we take a picture?
Yes, that'd be fantastic.
Okay, is there everyone's video on? Can we have everybody's video on? We have like 76 people joining. Wow, very good for a Saturday morning. Well done. Give yourself a pat in the back. I hope you all learned something from this section. Yay, one by one. So this is the first page. Smile. And then let's do the second page. I'm gonna do that again. There's a chat box. And if you want to say something to Sunny, turn your mic on. Young Coco, you seem very enthusiastic.
Thank you for the lesson.
Thank you, sir.
Thank you. Can't wait for the next lesson.
Yeah, thank you. Thank you very much.
Thank you for the insightful
presentation.
You're all very welcome. My pleasure. Looking forward to doing it again.
So maybe you can also tell us what would you like to learn more about in the next session regarding space biology, space medicine. So you know, we can cover that in the topic and as a topic. And you can join our WhatsApp group and tell me there as well. So because we want all of you to learn something and be inspired by space. And we need to solve this problem. So we need lots of people to work on it. I guess that's it for today. It's been 2.5 hours. Only supposed to be 90 minutes. But I take it as a good sign. So thank you, Sunny. It must be late for you now. Almost 11 o'clock.
That's okay. It was my pleasure. I appreciate all the enthusiasm and the great questions and conversations, and I had as much fun as I hope you all had. So thank you for having me.
Thank you. Thank you so much for coming. Have a good weekend.
Take care. Have a good night.
Take care,
Good day.
everyone.
Thank you. Have a nice
Thank you all.
weekend.
Thank you all.
Thank you. Have a great
Have a
weekend.
nice weekend too.
Thank you so much, Miss Anne,
everyone.
Dr. Sunny.
Thank you, sir.
Thank you so much, sir, and everyone.
Thank
Have a
you.
nice weekend.
Yeah.
Same to you,
Oh yeah,
sir.
and if you want, we'll be preparing a form for our mailing list soon. But just stay on the group either in WhatsApp or Telegram, and we'll figure it out. It's just so much to prepare right now. Good night. Good night. Good night, Sunny, and have a good weekend, everybody.
You too. Take care.
Take care. See you.
Thank you. Waiting for another discussion.
Sure. See you. James Webb. Hi, Queenie.